All right, so you've walked in, or maybe you've looked online and you're thinking about getting a variable speed pump. Or maybe your neighbor told you, hey, we just put one in a couple months ago and we can't believe how much energy we're saving, which is money, about 115, sometimes 150 plus per month off your bill. So let's look at this as kind of a simple way to figure out of these three or these two models, depending on which manufacturer you're looking at, why wouldn't the least expensive model do the job for me? And then we'll work our way up. And really, right out of the gate, the difference, the price difference between these is really, if you think about it, the one uptime, the upfront cost, a few $100s difference. And that will just disappear in 4 or 5 months because you'll get that money back off of the energy savings from your bill every single month. And that will go on for at least 10 years, assuming, that, something happens or the motor gives out. But these things are moving at half the speed, and they've been around since 2007, still going strong. So 20 years, you'll be getting that $125 a month back all the time. So let's figure out the first question to ask. Number one, how far away is your pump from your skimmer? That's where you empty, the leaves out of the basket. That run is how much pipe the pump is actually pulling water through. So if that's within 20 feet, now you've removed one possibility why this wouldn't work, the smallest version, the medium head. So you're good. Also, the next question, do you have a spa? Do you have water features, fountains, etc.? If you do, that's an eliminator, because this is designed just to move the water. A basic pool, no spa, no water fountains, etc. attached to it. That'll do the job in within 20 feet or so. Once you go to a fountain or a spa, you're looking at something like a high head, not necessarily the motor. This is a 1.5 horsepower. This is a 1.85, but the difference is the high head, the amount of water that this style of pump can move through it, and it costs less energy, therefore you don't need a monster motor. So if you're in a situation where you have an attached spa, you have a 25,000 gallon pool, you got 20, 30, 40 feet of pipe that you're pulling through, you would start here. And this is really like $150 more between the two. Now, if you have a spa, you have a waterfall, you have 35 plus thousand gallons, maybe you have a long run to your skimmer, then you're moving up to the flagship brands, the biggest pump that they make for a residential pool. This is I believe it's 7.5 or 2.85 total horsepower. And this thing is high head as well. But now you have the RPMs, you have the horsepower when you need to run the spa with your 6 jets in there and the water fountain and have the pool turning and filtering the water as well. So anyways, I hope this helped. Now I'll let you look at an energy calculator where we'll put in our California rates and we'll compare. You'll see the difference between your pump now and what would happen if you put one of these in.
This is a simulator that shows the pump interface, the computer, and when we manipulate the controls, you will see the watts and the RPMs. Above us is our energy savings. That's, I'll show you in a second. But right now, I want you to see that I have tried, even though I will not be able to do this because your single speed pump is running at 3,450 RPMs, not 3,000. This is the default setting. If you cranked a variable speed pump up as high as it can go, meaning topping out the RPMs, you're going to reach 3,000, and you're only going to hit 1,032 watts because of the efficiency already. But this is nothing. See, your single speed is pulling well over 2,000 watts, and it's pushing. See this number here? This is your flow rate. So your flow rate per minute, and this is your watts. Your flow rate with your single speed, you're hammering your filter system. If you have cartridges, that water is slamming those cartridges at 70 to 90 gallons per minute. When you install a variable speed, the whole magic is the fact that it has magnets. It's air cooled, none of that dirty air from outside. It's totally encased and sealed. It can't get in there and mess anything up. And that pump can run at whatever RPM you choose. And the RPMs that you're trying to set the pump at has everything to do with the flow rate. Now, this is assuming a 25,000 gallon pool that you're turning over running the pump 8 hours per day. This is what this energy saving readout is going to be based on. So now let's install this pump. Right now it's already saving you. Look, just setting it down and cranking it up as fast as it can go and running it for 8 hours, you're already saving 52%. So you're saving $90 or so a month. Per season, you're saving over $1,000, but we haven't even installed this correctly. We've just sat it down, hooked the pipes up, turned it on, and maxed it out and set it for 8 hours. You'd still save 52%. That's insane. But here's what we're going to do now. We're going to change the flow rate from 70 to 90 gallons per minute down to 31. And we're going to do that by varying, manipulating, telling the computer to change the RPM, slow down the magnets, etc. So here, we're going to drop the RPM until the flow rate is right around 31 and see how many watts we're pulling right now. So let's start dropping it. Watching it go down, watching it go down. Kind of a cool little example. Really works like this in real life because you have to wait a minute while you adjust for all the hydraulic pressure in the lines to equal out. Oh, a little bit lower. I think we're right about there, 31. Now, I was not looking at the RPMs. I was simply looking at my flow meter. And this flow meter is what we will have while we're installing. Well, actually, it's a physical device we put in between the pipe that shows us what the rate of the water flow is per minute. So now look at your watts. That's a 100-watt light bulb. Can you imagine going, 2,000 plus watts per hour times 32 cents? That's costing you about 78 cents an hour to run that pump. If you run it 8 hours a day, you're spending $5, sometimes $7 a day. Look what happened when we reduced the runtime, not the runtime, but the RPMs to the right, reduced the flow rate to half, which reduced the RPMs dramatically. And now you're not spending 2,000 plus watts per hour. You're only spending 100, maybe 125. Look at the dramatic savings. This would take, in this scenario, $162 off your PG&E bill. Per season, you're saving almost $2,000. And this is going to happen every single month, every single year, for bare minimum 10 years. Now, there's been variable speed pumps out since 2007, and they're still running strong after 14 or so years. These pumps are anticipated to last much longer, 20 plus, because they're only running at half the speed, less wear and tear. So now I want you to look at this. If there was any piece of equipment that I was considering changing at my pool, if everything's working great, I would not spend $1 on anything else except getting a pump that's going to pay me back $162 for 10 years, if not 20 years. And that's what I wanted to show you by taking a look at this. If you have any questions, we can run through this simulator on our iPads or on the phone. We can even go to your house, put the right equipment as far as our measuring equipment to show the amps of your current pump, how long you're running it, etc., and give you exactly how much you would save per month.
You can get all this information on other videos around the store about different topics, or online. If you sign up for our Pool Tools newsletter, you have access to the whole catalog. Hope this helped. Thanks a lot. Bye-bye.
Online at hallpoolsupply.com.